This one, let's take a look at using L'Hopital to find the limit as x approaches 0 of sine of x over x. So first of all, observe that sine of 0 divided by 0 is 0 over 0. Sine of 0, if you reference the unit circle as I have a portion of it drawn here, you see, for example, you see where it says sine of 0 equals 0. Remember that the sign of the function on the unit circle is just the value of the y-coordinate at that point. So that point is 1 comma 0, therefore the value of the sine function is 0. So up here you have sine of 0 over 0, which is then 0 over 0. That clearly is not defined because you're dividing by 0. Therefore, that tells you should use L'Hopital. L'Hopital states you can find the same limit by differentiating the top and the bottom individually. So look on the bottom lower right-hand corner for notes. It says that following, that the derivative of sine of x is cosine x, the derivative of x is just 1. For that reason, back at step 3 here, you replace sine of x with cosine x. On the bottom, you replace x with 1. You've differentiated the top and the bottom individually, not using the quotient rule. Then you can simplify that, so cosine of x divided by 1 is just the cosine of x. At that point, to evaluate, you simply replace x with 0. I do that at step 5, you see cosine of 0. And at step 6, the value of cosine of 0 is 1, and that is the final answer. Therefore, the limit as x approaches 0 of sine x over x using L'Hopital is 1, which is shown in step 6. Remember that the cosine of 0, if you reference the unit circle again, is just the value of the x-coordinate at the point 1 comma 0. The value of the x-coordinate is 1, and that's why the answer at step 6 is 1. And that's it.